Well, I'm going to use some basic ideas of log again in this question. I hope you have seen the answer or solution for the last log video. If not, then go back and check that. So this is another log video, log question. Uh, now, I already discussed this in the previous video, but depending on whether you have watched it or not, the basic idea of log is this. So I'll use this idea for the for firstly this part. I mean, whenever I'm looking at this, I'm noticing something like this. What power of root 3 will give me 81? Now I know root 3 squared is 3, that squared is 9, and that squared is 8. Something like this, right? So 81, I mean. Root 3 squared is 3, that squared is 9, and that squared is 81. So effectively, this is root 3 to the power 8 is 81. So this result is 8, straightforward. So if you're good with it, you'll identify this thing very quickly. So this is 8 minus 7, 1, this last two terms. Now all I have to do is figure out this thing. Now here I'll just explain some basic ideas of log again. One idea is this, because see, I hope you understand from here that log and indices are interdependent to each other. So it's like an inverse function kind of idea. So now, if you check this out, I mean, a to the power b whole to the power c is a to the power b into c. I hope you know that, right? If you don't understand these basic, just take example and understand whatever is a to the power 5 meaning and cubing that what results. So it's a to the power 5 into a to the power 5 into a to the power 5. You can just take examples to understand these kind of things. So you have a to the power b whole to the power c equal to a to the power b into c. So effectively what is happening? So if I have a value which is in the power form and I raise it to another power, the power gets multiplied, right? But log itself is the power, isn't it? This is the power, right? The log output itself is the power. So if I raise the number by something, then that, okay, let me not use P again. So if I use a Q or something, so this power, or what I mean by that is not this, I mean something like this. So if I have something like this, so this is the power form, right? So whatever power of B results in N, that multiplied to Q will result to N to the power Q, right? Using this idea. If not, you can use examples to understand that. But the property that I'm talking about is this. This is one idea that we are going to use. These are equal, by the way. And the other idea that I'm going to use is very similar to this. Let me take an example to explain this. For example, log 16 base 2. Log 16 base 2 is 4, right? But if I, okay, so don't get confused here. I took a very bad example. Let's say log 64 base 2. So log 64 base 2 is 6, right? Now check this out. I mean, if I do log 64 base 4, now again, why is log 64 base 2 equal to 6? Because 2 power 6 is 64. That is the question, right? Whenever you have this log thing, just ask yourself this question: which power of 2 gives us 64? So if it's an integral one, you can understand that or figure it out. If it's not, then you would have to refer to the log table. But check with integer powers itself. Don't overcomplicate stuff. Now, think this through. I mean, 4 four's third power is 64, right? But then why is so? Because what we have done is from 2 to 4, we have squared this number, right? Now, because you have already squared this number, a half of this power will be sufficient, right? Because the idea is 2 square raised to 3 should be 2 to the power 6, right? So this is the idea that is happening. So essentially, the property that we are also using in this case, so I'll just write these two properties afresh, and I'll write a shortcut to this as well. So one property that we are going to use is this. Let me write this P only. One is this property that I've already discussed. Another property that we're going to use is something like this. So if I have this is the base, let's say. This Q will actually come in the denominator because check this out, log 64 base 2 is 6. Log 64 base 4 is 3, but then how is that 3 coming? Log 64 base 2, half of that, right? This is 6, right? Half of 6 is 3, right? So this q is going to come in the denominator, and we are going to have something like this. I hope this was understood. I cannot take too much time to explain this. In our classes, we have done this in very much details. So a combination of these two will arrive, I mean, you'll arrive at a relation like this. Log of n to the power p base b to the power q is equal to p by q log n base b. So this power comes, I mean, whatever is the power here will come outside in the numerator, and whatever is the power of the base, if you take out that power, that will come in the denominator. So that is the picturized idea, but this is useful. I mean, this idea is most useful in these cases. So suppose you have something like this and something like this. Now what I can do is I can get this a out and b out. Let me take these things off. I hope this was understood. Don't get confused here. So I can just take this a and b out, and then I'm left with log x base x, which is simply 1, right? So this will always be a by b. So this is very useful in these kind of cases. And this is the case that is happening in the first part. If you notice this properly, let me take all of this thing off. So I'm just explaining the basics here. This root 5 that we have, first of all, is 5 to the power half, right? So let's keep a note of that. Also, this 0.008 is simply 8 by 1000, which is 2 cube by 10 cube, right? Which is simply 1 by 5 cube, or effectively 5 to the power minus 3. So this is another thing that we have. But check this out. Both of these are powers of 5, right? So I can write this expression as something like this, right? I'm just replacing everything here. So this is similar to this idea, isn't it? You have the same x and x, so 5 in this case. The half will come out and the minus 3 will come out. The rest of it is 1. I don't care about it. So this is minus 1 by 6. So now you know that this is 8 minus 7, 1. So this results in 1. And this results in minus 1 by 6. So effectively, if you add these two, you get the answer as 5 by 6. So it depends on your comfortability with log. This can be very, very fast. Trust me on it. I mean, if you relate these things in this way, you can solve this question very fast, and even with a bit of practice mentally even. But then it depends on your comfortability. So I'll say the ideal time, whatever it is, it doesn't matter. You don't have to know too many properties anyhow. Just a basic understanding of those properties is sufficient. But ideal time to solve this would be 2 to 2.5 minutes. I would say 2 to 2.5 minutes is an ideal time to solve this. It might take a bit of more time for you. You might solve it in a little more time. But then ideally, if you are good with log and everything, or understand the properties properly, then you should be able to solve this in 2.5 minutes, definitely, not more than that. So that's it for this question. I hope this was understood. If not, just contact us. We'll help you out a bit. In our classes, we have explained these logs, and I mean, in the classes, I've actually drawn relation between the indices and the logs as separate table. For each property of indices, I've correlated the property with the log, and that is very visually understood. I mean, you can remember those kind of things very easily. You don't have to remember it actually. You'll understand all of that. So that is it for this question. I hope this was fun. Thank you.